Exhaust gases are very corrosive, and because they cause exhaust gas recirculation valves, or EGRs, like this one, to fail. Our EGRs feature a corrosion-resistant stainless steel sleeve which covers the internal piston. More important, the piston beneath that sleeve is coated with black PTFE, similar to Teflon. This also resists corrosion and prevents the piston from sticking, another common failure mode. The benefits? Less corrosion, superior wear resistance, extended life, performance, and reliability, and of course, satisfied customers. Advantage, Wells.
Welcome to another live Wells Tech training event. We are so happy you are here. All right, today is for everyone who doesn't do it every day. And what we're going to do is get that lab scope out of the toolbox and get it on the car and start doing some checking. And we're going to go through the steps it takes to get you there. Now, we have talked to many technicians on the phone that are reluctant to even pull their lab scope out. And we're going to talk about why that is and how to cure that. And I got Dave Miller here today to give me a hand on that. Okay, but before we bring Dave in, let's talk about the t-shirt. Yes, winning one of these t-shirts. Wouldn't you love it? Yes. These are great t-shirts, by the way. Love them. They're very comfortable. All right, first one in with the correct answer will have a t-shirt sent out to them tomorrow. All right, this is a very fitting question because as of yesterday, Wells Vehicle Electronics is now part of NGK. NGK bought us about 3 months ago, and the complete conversion occurred yesterday on July 1st. And we are now part of NGK. So, with that in mind, what was the first Japanese car to be produced in the United States? What was the first Japanese car to be produced in the United States? And it's gonna be multiple choice this time. All right. A, Honda Accord. B, Mazda Miata. By the way, we got a Mazda Miata case study coming up here pretty soon. C, Toyota Camry, and D, Nissan Maxima. So text in the correct answer, Honda Accord, Mazda Miata, Toyota Camry, or Nissan Maxima. And first one in with the correct answer will get a t-shirt. Okay, Dave?
Hey, Mark.
Come on in. Let's show what we have here. This is Dave Miller. And you've met Dave Miller before. He's been working here for a couple years, right?
A couple years.
Prior to this, for over 40 years, he worked at an engine rebuilding shop. And he was the lead diagnostic person. Okay, so being the lead diagnostic person at your old place of employment, how often did you pull the scope out?
Not enough. I was one of the guys, as you mentioned, afraid to use it.
Afraid to use it?
Well, basically because it was just not the knowledge there, and I would get it out once in a while. It would take a little bit too much time, and I usually took it out when I had a problem and got to that point.
Yep.
And I'd start to get to learn to use it, except it'd be another month before I'd get it out again.
Right.
And then there I'd be back almost at square one because you forget
learning
it over
again.
again. Yeah, and I just,
right.
It was many times where I'd put a part on a car and then that didn't fix it, and then I finally got to using the scope.
So it was a last resort.
Yeah, it should have been the first resort.
And one of the things you said was you didn't have time to get it out, which is very interesting. And when you say time, it doesn't necessarily equate to times or seconds or minutes. It equates to money.
Right.
Because if you're spending a lot of time getting up to speed before you even use the tool,
There you go.
That's not a good thing.
Right.
Right, and that's very frustrating too, because you're under a lot of pressure, your boss wants this thing diagnosed, and here you are reading the manual on your lab scope, to get it going.
Right. Well, everybody wishes that they could put their scanner on there, which is what you all do first, and look at a code. Oh, it's the O2. And it'd be nice that you could just go put it, well, everybody knows it doesn't always work that way.
No, it very rarely it seems.
You got to do some diagnostics.
Right, you got to do some diagnostics, and in order to do those diagnostics properly, you have to use a lab scope. There's no way around it.
More so now than ever because of all electronics on the cars, and especially a lot of the old sensors were magnetic resistors. You could get an AC reading. Well, now they're Hall effect. You don't get much out of them, and nothing in there that's going to help you unless you put a scope on it.
The meter is not going to really help you at that point. And one of the problems with the meter is that it'll read a good meter will read about 5 times a second. And that seems fast, but when your computer is working over 1 million times a second, it's not fast enough to keep up.
Right.
Okay? And that's where a lab scope is. It'll work just as fast as your computer in your car.
Find the glitches.
Right. It'll find the glitches. And that's what you need today. And we're constantly getting calls on intermittencies, and it's very difficult to find them without the right tools and the knowledge to use it. So there you go. That's now. How do you feel about using them?
It's great, and now that I know how to use it, it's a time saver.
Right.
Big time saver.
Exactly.
Because you put it on there and get, as an example, checking compression on a car nowadays is a lot of work. A lot of them where you got to pull an intake. Put a scope on it, you can have it done in, at the max, 15 minutes.
Yeah.
But I mean, by the time you look up everything and get hooked up, compared to basically hours. Take a Ford.
Sure.
It takes you a couple hours to check all 8 cylinders on one of those.
Yeah, absolutely.
Scope.
And when you said time saver, to me that equates to money maker. This is a money maker.
Big time.
If you learn how to use it properly. And that's what we're going to focus on. We're going to start right from the very beginning. Okay? As far as how come there's only one ground connection on here?
Right.
Right? Why is that?
Because you only need the one ground connection, and the other
These are
cables
all
are
connected together. At the ground, right? Okay, so there's a question right there that Dave had when he started playing with the lab scope, and there you go. If you have that question, that's why it's a common ground for each one of the channels. And you only need one ground.
Right. That's why the first couple cables will have the grounds on and from the cable going over there, and the couple, the last two will go off of the other ones.
Right.
And that was also a question to me when I first started using, what's going on here?
Right. Okay. So now, one of the things you want to do too, and you learned that when you started here too, is you want to be organized with your stuff. Yeah, especially when it comes to your lab scope, because you don't want to be chasing around the shop looking for your cords, your leads, and all this other stuff. And so what we do is we have them in these little pouches. We have all of our leads in there, and then we have all of our stuff over here, different leads that we can use if we need them. We got our fuse buddies in here, and we also have our amp clamp right here. And also what we have in here is this guy right here, which is your banana plug replacement. Right, be sure and have that. That kind of stuff. So it's all right in one spot. So when we grab the scope, that's all you got to do is grab this stuff, grab the scope, boom, you're right there. Yeah. And also back probes.
That was also an issue with me. They didn't have these type of good acupuncture probes back when I was first using the scope. And sometimes I'd have a paper clip in there, and you don't make good connection, and then you don't get a good waveform. Is it the part? Is it my waveform? Is it my connection? What's going on?
Is it my leads? You don't know at that point. And having a good back probes, and we keep stressing this. I know you're probably sick of hearing about it.
So important.
But it's so important to have a good back probe. And when we work on this, what is this, a 98 Grand Am, we'll try back probing it with a couple different back probes that we have, and we'll see what works the best. I'm telling you, once you get these acupuncture back probes, you'll never go to anything else. They are just awesome. We'll get some of these.
Great.
Okay, so get organized. Get your stuff together, so you know where it is. You don't have to be searching around for it. The first thing you're going to do, let's say a car came in. Let's say this 98 Grand Am came in with a TPS code in it. Because the first thing we're going to do when we diagnose anything is you're going to put a scan tool on there. You're going to see what the computer has. Do we have any codes in here? What is it going to tell us right up front? So once we put the scan tool on, what's our next step? To go out there and test the TPS, or what should we do? You know, the next step is to go to the computer, correct?
Right.
And that's another thing. Computer goes hand in hand with your lab scope. So if you need to get some experience on the computer, do that. Computer today is a tool. It's a tool that you can use, and it's a time saver. It's a money maker. That's how you make money these days. And you gotta either be a member of IETN or Identifix or something like that. And what we normally do when we're diagnosing something is we'll get that code, we'll go in to our office, and we'll work on the computer. Look it up on Identifix, look it up on IETN, look it up on all data. Get the wiring diagram for it so you know which each color wire is and all that. That kind of thing, because computer is a moneymaker today, and it might lead you in just the right direction. Maybe that TPS had problems with antifreeze getting in it, right? Or who knows? Who knows? And at least it'll send you in the right direction. Or if it has a very common problem, when you're doing the job, take special note of that and look. See if there's wires rubbed through in this area, that kind of thing. Okay, so you got to work on the computer, and by the way, you got to charge for that too. If you spend 15 minutes on the computer, it's 15 minutes worth of labor, okay, because you're fixing a car. Even though you're on a computer, you are repairing a car. Okay, wiring diagrams, they are optional. I like them. A lot of lab scopes today, especially like this one. By the way, we use the Snap-on stuff not because we love them the best, because we felt they were the most popular. That's why we purchased these. There are a lot of different lab scopes out there that work real well. We got a new one coming, a one-channel one. We're going to try that out too from AES Wave. We'll let you know how that works too. And so you can look up pinout charts on here.
Yeah,
right?
and
You go under. Get there?
You go to component locations.
Component locations.
And then you
okay.
put in the make and model, and then you go to component location, component tests, I should say, and it'll come up with the different tests. You hit what you want to look at, and it'll usually show you the pinout.
It'll give you the pinout, so ABC.
And the best location to get it.
Right.
But
okay. Well, that helps.
Not always accurate because there's too many different variances,
Right.
but that's why you want both.
Right.
And generally it works out, but
Yep.
every car is
this
different.
This way, let's say we don't have a 5-volt reference and we want to go back to the computer and check to see if we have a 5-volt reference coming out of the computer, make sure it's not in the wiring, right?
Yep.
This way we got it right here.
Yep,
and
you
we
can
can
see
go
the
right to
pin
it right
out
away.
for it.
Right. So it's always good. It's always, to me, I always print out a wiring diagram and that's your map. So it's up to you, so whichever way you want to use, but just remember, this isn't always accurate and this isn't always accurate either. So
The more information you got,
the better
off you are.
chances are.
Yep.
Right. Okay. Now what we're going to do is we're going to talk about the grid, or the face of your lab scope, and what that means, what it's telling you. So in the meantime, why don't you go over and start getting hooked up on the car, and then I'll meet you over there.
Sounds good.
All right. Got enough arms?
Yep.
Okay.
We made
All right.
it.
I'll see you in a minute. Okay. We look up over here on our whiteboard. We do have a grid, and the grid like this will always have an X, X, and it'll have a Y axis. Okay, and the horizontal line is the X axis, and the vertical line is a Y axis. The way I always remember this, and you know, it might come in handy. I don't know if you really need to know this or not, but the way I always remember it is Y to the sky. Okay, so Y is our vertical, okay, grid, and X is our horizontal. Okay, with the grid, you have dividers, 1, 2, 3, 4, 5. You can have a number of different dividers in there, depending upon how you have it set. But what this means, X is our time. Okay, this is how long our signal is going to take. Like, let's say we had a line that came from here and went all the way over to here. Because there are 5 divisions and we're at 1 second per division, for this line to get from here to here, it will take 5 seconds. Okay, that's what our x-axis is, time. Okay, y is our amplitude. Oops, I spelled that wrong. Here's an I right there. Amplitude, which is our voltage. How high do we set our voltage? And this also has 5 divisions in it. And let's say it's set to 1 volt per division. So if we had a signal that got this high, that would equate to 5 volts. All right. And the reason why they call this as a grid is because we're going to do voltage over time. And let's say we are testing a TPS, and it starts out at 1 volt right here. Okay, and we work the lever on the TPS back and forth. We work it one way, and we get a signal similar to this. Okay, so what this is telling us is for this to reach 5 volts, let's say this is the point that it reached 5 volts, and if we draw a line straight down from that, we come almost to the 3. I don't know if that's a straight line or not, but you have to bear with me. And down at the 3. So if we want to analyze this, it got to 5 volts in 3 seconds. Okay, that's our grid. That's how it works. And TPS is an analog signal. And another thing that speeds up the use of a lab scope is to have a general idea of the pattern you should be getting off of the part that you're testing. Okay, so you got to kind of have a good idea. Okay, a Hall effect, I should be getting, if it's a 5 volt reference Hall effect, I should be getting a 5 volt on-off signal. Okay, frequency is going to determine how fast the engine is going, or the time, frequency or time. It's going to depend upon how fast the engine's running, that type of thing, okay, as to how frequent that signal is going to occur. But if we're looking for a 5 volt signal, we should be going from near 0 up 5 volts and down. That's a digital signal. What we're going to get off of the TPS is an analog signal, meaning it's going to slope up and it's going to slope down as we move the lever. And I'm sure you've all seen that, but we're going to do it again for you, right on the car, step by step. Okay. All right. I think Dave is ready at the car. I'm going to go over and join him. And why don't you come along? Come on. Okay, David.
Hey, Mark.
Hey, you're over by the
Yep, got the stuff over here.
our 98 Grand Am.
Good car.
That's what we're going to see. Good car. Good 3100. That was a good engine.
Yep, 200,000 plus.
Yep. Okay, so what we got going on?
Well, what we're going to do, got the lab scope getting ready to get set up here. We're going to take a look at the throttle position sensor,
Okay.
the output signal on it.
Yep.
And I got everything ready to go here, and we're going to show step by step how to do that.
How to hook that up?
Yep. We're going to
start
use,
from the beginning. All right.
it's going to
good.
be this is a 4-channel scope. We're going to just use the 1 channel.
Okay.
the
Let's
first
tip
thing.
this up so
Yep.
they can see it.
Right.
Okay.
Get it
right
up
there. All right.
Right, and here we have the first cable, and notice it's yellow, and how you got the 4 wire colors on here. Mm-hmm. That's fairly important because the first 2, the yellow and the green, those have the ground in it. If you were to
Okay.
take a red one and put in there, you wouldn't have the ground.
Right. And what he's
obviously
talking
wouldn't
about
work.
here is this scope has 2 special wires like this, and they go into the first 2 channels. And the reason for that is you got your ground connection onto the same cable. And this ground connection, you cannot attach anything to it. It's got a blunt end. This one here, you can attach other leads to it, and we'll show you how that works here in just a second. All right, so the first thing we're going to do is we're going to take our yellow lead and put it into channel number 1. Okay, now we also have to have a ground for this, right?
Right.
So we're going to allow the ground connection to connect to the ground plug. So we're going to use the one that you can connect to, not the blunt end one. Okay? So there's our lead. Now we got to hook up the ground.
Right.
Okay, this one you can use any color wire you want. It doesn't matter. And you can see it's not black, it's red, but it's our ground. And we're going to take the one end and punch it into our ground point. And we're going to take the other end. This has got a banana plug on it. And you can use alligator clips, any type of alligator clip you want with a banana plug on it. And we're going to hook that to battery negative.
Right here.
That's the best place to ground. If you can't get the battery negative, you should go right onto the block of the engine. Okay?
Okay.
And is our screen okay? How's our screen there, Brian?
Oh, screen's excellent.
Okay, good. All right.
Okay.
So now we're going to hook up to the TPS, right?
Right.
Okay.
Of course, the first thing, you got to know what you're going to hook up to.
Let's do the overhead camera.
Okay. The first.
There we go.
Okay. We all set?
Yep.
Okay. You want to know where you're going to set up on, because of course there's 3 wires: the power, the ground, and the signal. So I always go into the computer first, and got the printout. This is off of all data. Right here's the TPS sensor, and it shows me that the dark green wire is the signal.
Okay, now they could also get that information off the scan tool, right? Or
Right.
similar information. We could get the pin out off the scan tool,
Yep.
but as long as we're in the office looking at Identifix or whatever we're looking at before we start repairing this vehicle, we always print off the wiring diagram, and that way we have a complete map of what we're doing. Let's say we want to get to the computer. We already have it there. We don't have to go back into the office and print something out. So as long as we're there, that's why we do it.
That's why we do it.
Okay?
Okay, in this particular vehicle, back even in this day, had a fairly tight weather pack. They were stuffed in there pretty good.
Yeah, remember this is a 1998 vehicle. The weather packs today are much tighter.
Yeah. And what I want to show here, this is the type of connector that I also got stuck using. It's a lot thicker. Here's what we've been trying to show you all along here, the real thin one, nice point that we get from ASC Wave. And it's even got a nice banana plug end on, so it's real easy to hook up.
Right.
And I'm going to show you, it's not too easy to get this one in there. I used to even grind the end a little bit.
Yep, that would help.
And it's hard on the connector, but you get down here and you get on that wire, and I'm pushing on there pretty good.
I can see you're pushing on it.
see it's
You're
even
actually
push-
going to bend it if you're
Yeah,
pushing
it's
it
pushing
harder.
the plastic around there.
So you can't get that one in, is
You'd force it. And it's not good for it.
right, and it's going to wreck the weather pack. That's for
And
sure.
what was even worse was paper clips, which
Yep.
it's better than nothing, but you're a lot
Yeah.
better off with this.
It's
here.
better than piercing a wire, but not much.
All right, so now watch this. Get right there and it just slips right in there.
Whoop,
Then
goes
you can
right
feel
in
it hit
there.
the connector part in there. You know you're making a good connection.
And now we also had vehicles that you absolutely could not get any other lead
The
in.
later, I had a 2008, I believe it was a Ford, a few weeks ago, and I had a fairly hard time even getting that one in there. But it
Right.
worked, but I would have never, ever gotten this in there.
Right.
It just wouldn't have happened. So then
Okay,
you got the nice
hook
banana
up your
clip
banana
end,
plug,
and
and we're all
should get
set
a
to go.
signal there. Getting something there.
Okay, good.
Switch the camera over there.
All right. I think we got a bad ground. This is what a bad ground looks like. You want to see it?
Yep. So wiggle here, go up on that end there.
Do you have the key on? Or
Key's
no
on.
power? Okay.
Yeah, keys on.
All right.
Remember we had that on the first one here too. Anything?
Nope.
Well, I'll try this again. Anything?
Nope.
Well, that's strange. It's been working
Well,
all day.
we may be there. I'm just maybe not looking at it right. Okay, go ahead and
Let's see if we move it.
sweep it. Nope, you don't have a connection there, Dave.
I wonder why.
I don't know.
Battery went dead on the car.
Well, this is what
There?
happens when it doesn't work right. Are you sure the key's on, Dave?
Yeah, I'm going to try it
Let's
again.
check that.
Key is on. I'm going to see if it turns over. Yep.
Okay.
We know we got power.
Yep.
And I don't know why we're not getting
Well,
it.
you see, guys, this doesn't always work for us either. And
Yeah.
if you don't know what to do, why don't you come up to this front camera right here, Brian? Thank you. If you don't know what bad looks like, you'll never know what to do about it. And obviously we don't have a good connection here. I think we have a good ground, we just don't have a connection onto the back probe. But even with a good back probe, it's hard sometimes to get a good connection. No, I think it's down there, David. It's not up there.
Well, I have one in here.
Let me give her a try.
Yeah, maybe you'll have better luck.
Okay. Yeah, felt like we were on it. Change?
I'm gonna go with it. I'm just trying something here.
Did it change?
We got her now, I think. Getting something here, or else we just...
I just disconnected
No,
it. We had...
no, now it's like a bad ground.
All right. David, just leave it alone, please.
Okay.
There.
We got it.
All right, yay!
I think, well, at least we're back
All
up
right,
to
let's
that.
do it then. Thank you.
Maybe not.
Okay. All right, so let's come back to the screen. There we go.
There we
All
go.
right. Sorry about that. All right, first thing we're going to do is we're going to look to see how our scope is set up. And I got to turn it on here. And the first thing we're going to look at is our voltage. And right now, it's set on 2 volts per division. The thing is, our division on this is from here, wherever 0 is here, right here, up to here. That's our division. So it's 2 volts from here to here. So we're set too low. We know that this is a 5 volt sensor. It works off a 5 volt reference and it goes up to about 4.5 volts. So what we need to do is we need to go up to 5 volts. Okay? And now we're on 5 volts per division. Let me show you what that looks like. Okay, so here's our 0 right here. And if I move our line down a little bit, we'll be able to get this down here closer. There we go. 0 is right here, and 5 volts is all the way to the top. Okay, that's our division. And also our time is on 5 seconds. That means our signal, if it went from here to here, it would be 5 seconds long. All right, and we do have divisions. Here's 1 second, 2 seconds, 3 seconds, and on. Okay, Dave, go ahead and sweep it once. Okay, there's the sweep right there. I'm just going to stop it. And right here, he started the sweep at about 2.5 seconds, and he ended at about 3.5 seconds. That means his entire sweep took about a second. Okay, 2.5 marker, 3.5 marker, it's about a second. To get to 4.5 volts is right here. Okay, so if we draw a straight line down, by the way, there are cursors that you can bring in on LabScope. We'll show you how to do that in a little later class. But right here is our point to get to 4.5 volts. Right here, we started at 2.5, so about, it took them a quarter second to get up to about half a second to get up to 4.5 volts. All right, so now let's do a little experimenting. And let's see what happens when we don't have it set right, or for something different. Let's see, let's go a second per division. Okay, so now our time scale has changed, but our amplitude scale, our Y scale, is the same. Okay, so here's our 0, and here's 1 second. So it's 1 second from here to here. All right, Dave, go ahead. Now you can see what happened to our slope. It's virtually the same slope as what we had before, but we're taking a closer look at it. It's like a magnification of that slope. We're taking a more detailed look at each one of these lines because we changed the time factor. That way we can go in and look at each part of the slope that we need to look at. So we still have it. It's still the same signal. It's just a different way of looking at it, and we can move it around and look closer. All right, so let's go back here and change this to 5 seconds per division. And I'm going to go up and I'm going to change the voltage. Now, we know it's putting out about 4.5 volts, but I'm going to change it to 2 volts per division, and we'll see what happens to our pattern at that point. Okay, Dave, go ahead.
Here we go.
right there. You can see here's our pattern. And again, it took him about, our time scale is about the same. It's about a little over a second that time. But then when we go to look at the top of our pattern, it's gone because the limit is 2 volts, because it's 2 volts per division on this scale. Here's 1 volt, here's 2 volts right there. So it went right off the top. Let's go one more little experiment here. And I love experiments, by the way. We're always looking for that big explosion. Let's go up to 10 volts per division. Okay, so now we doubled our original setting. So now we're on 10 volts. So it's 10 volts from here to here. So go ahead. All right. Now you can see we got the same pattern, but it's smaller and it's less detailed because we're looking at it on a 5-volt scale and we're looking at it on a higher voltage than we need to. So when we get to a closer voltage, we can, what that does is it virtually allows us to zoom in on that pattern and look at more details. And we'll get more into how to manipulate your scope in future training classes. Okay? All right. Now, with any good school, they'll always give you homework. So we got to give you some homework too. What I want you to do is grab your scope. First, organize your leads. Remember, we talked about that right away, and I can't stress how important that is. Get everything organized. So when you go to grab your scope, you can grab it all at once, and boom, you got everything you need right there. Okay. Then I want you to check 2, 3, 4 TPSs, and play around with the scope yourself. Do it at a time that nobody's going to disturb you, like at night before you go home. Spend 15 minutes doing it. And if you do that for a few nights, you'll be surprised how much of a difference that makes. It'll just get you a lot more familiar with it. All right, anything else you'd like to add, Dave?
Well, just when if you ever are testing one of these, what you'll notice, when you do get a glitch, it's just going to be coming up. You'll see the dropout.
Right, you'll see a spike that'll go completely, usually down near 0.
Very hard to do with a voltmeter, but on here you'll pick it up.
And that's
really
a good
easy.
point too. Remember, our voltmeter is only looking at 5 times per second. And that's why when you sweep it with a voltmeter, you got to sweep it real slow, because if you go too fast, you're going to miss that glitch. With a scope like this is looking at it 1,000,000 times a second. It's the same speed as your computer, okay? Even faster than that. But you don't have to worry about how you sweep it. Just sweep it and look and see if you got a glitch. Okay, very good point. Okay, did we get any answers?
Yes, we did.
Okay, nice. Oh, good. Good. I like multiples. Honda Klaus. Okay, that's from Honda. Hey, Honda, you just won a T-shirt. And first Japanese car produced, Honda. Yes, it was. And that's from Barry Gable. Okay, we're going to give a shirt to both you guys. You both came in at 12:06. It's a tie, so you both get a T-shirt. You want to bring my email address up, Brian? Thank you. Send me an email with your shirt size and your mail-in address, and we'll get that out to you on Monday. Okay, because we're not here tomorrow. We got off tomorrow. All right.
Great.
Anything else?
Just have fun with it.
Have fun.
And
That's
it is
right.
fun. Once you start learning it, it's really enjoyable because you get
And
to
you
know
can
what you're
see that
doing.
we have problems too,
Oh,
but
yeah.
we stuck with it and figured out what was wrong and got it to work. But now you know what it looks like when it doesn't work too. So there you go. That was a great lesson.
Yep.
All right. Without you being there, we would not be here. We appreciate you being there, and we'll see you again next time in a Wells Tech Garage.